understood somewhat into the mathematical formula like this is very easy to represent. So you can see whenever you had some initialization of the you can say some initialization of the nodes, or you can also call it as inputs, you obviously going to be get as a weights, whether it is the different kind of the initialization weights. So according to whatever we learned just now, it's going to be get as some of the inputs, along with whenever you represented with respect to the previous timestamps also, this previous timestamps also having some weights, right? Having some weight, this is also having some weight whenever you represented with some of the other previous timestamps also, and also the future cells. So it is also eventually going to be give as some wa results, you can say. So if you just concatenated with respect to your, this is sigmoid function obviously. So if you concatenated with your sigma function with input layer and also the previous ident stamp what we had, and connecting to your memory, whatever the information you are going to be retrieved. So this is how we are going to be represented as an input gate. So I is nothing but an input gate here. So you can see you're going to be retrieved. So what exactly the LSTM cell does when compared to the RNN. So you're going to be get the input for for any kind of you can say RNN also does the same thing. But what will happen? How much it's going to be learned, or how much is going to be useful? It will take. It will take, and remaining, it's going to be mug up, or it's going to be forgot. So what will happen eventually? You have a long sequence. Yeah, let's let this space. You have a long sequence. So if you apply the LSTM layer, it's going to be learn something with respect to whatever you want, with corresponding to the cells, or you can say corresponding to the classes you are going to be perform, or maybe the some other task like classification or regression task. It's going to be learned on top of these. Okay, it's going to be learned on top of this. Whoever having the important information, or whoever having the advantage of the information, it's going to be preserved in the cells, and whoever don't have that much of preservations of the information, it's going to be forgot. It's going to be forgot. This is all going to be forgot. So eventually what will happen, it's going to be truncated some of the cells. So what will happen, whatever the long sequence, it may not be preserved that much of the long sequence, but it will going to be truncate, and also going to be get as a, some short sequence kind of the thing. So that's how the simple terms we are going to be understood in the LSTM, I can say, because what will happen eventually, you're going to be forgot something. So in the RNN, we don't have any concept of the forgot cells. So that is some disadvantage with respect to the RNN. So ideas came into the picture whenever you learn something. I mean, whenever you get some problems, right? So eventually, whenever you get some problems, you're going to be get some solution according to that. Even that solution may not be works on, you're going to be get the solution too. Even it's going does not works out well, it's going to be get solution three. Like that, it's going to be works out for the deep learning mechanisms. So if you take any kind of the problem, you have to try to solve with respect to the different solution. It may not be easier, or it still it has some of the disadvantages. It still has some of these disadvantages. You cannot be preserved that much of this is a best solution, this is not a best solutions. So eventually what will happen, it will works out with the small sequences vectors, and it may not be works out with the longer sequences vectors. So let's try to understand the other cells. So I already said something called as a candidate or memory kind of the cell. So this is how this cell representation is going to be works out. So whatever the input get information with respect to the input value we had, it's going to be preserved with respect to the TANH activation function. So TANH activation function, it's also kind of the function. I think we're going to be discuss maybe the activation functions we are going to be learn. TANH function is going to be lies between -1 to +1. So what will happen eventually if you apply the TANH function with respect to whatever the information you are going to be get from the hidden state, or you can say whatever the information you're going to be get from the hidden state, it's going to be just you can say addition or some concatenation with respect to that, then it's going to be produce some output. Again, it's also preserving some TANH results. So this is, I can say, this is architecture of the LSTM cell. So we are just learn whatever they implemented with respect to the LSTM model. So So eventually what happened, it's going to be forget something, and it's going to be take the information, then it's going to be preserve that output in the into the next cell. So it will pass to the next cell according to the t time sequences what we had. So if you understood these concepts, you try to easy to write these equations easily, very easily. So if you just understand, this is the input information according to the weight, this is the previous hidden state according to the weight, this is some bias. If you want to, you can showcase as a bias. If you don't want, you can ignore this. And similarly, the tan H activation function, this is sigmoid activation function, this is some concatenation with respect to the two different functions what we had. And generally you're going to be get hidden state with respect to the next cell state, this cell state. So similarly, what is the disadvantage with the LSTM means, so whatever you learn with respect to the long sequences, you're just a truncating, or you're just going to be truncated with respect to somehow other sequences or other sequences. So some of the information you may lose. Okay, some of the information you may lose. We can also call it as a data leakage for that matter, data leakage in terms of the model building or runtime data leakage at the time. So what this is the sum of disadvantages in the LSTM cell. It may not also somehow preservative with respect to some other good kind of the words may be present in this area. So what will happen, if you go and discuss in the LRU concept, you will slightly get some different gates, something called as a reset gate. So we eventually go and learn this. Let's try to understand the IPython notebook, how to implement by using our sequence data what we had. So I'm just importing some of the number of the units, whatever the input units we had, along with the samples, and according to the number of the inputs we are going to be showcased and number of the classes. So yeah, eventually this is some custom implementation, I can say. We are not writing. If you go and see the scikit-learn documentation or TensorFlow documentation of the LSTM cell, that is very straightforward, I can say. If you directly learn from the custom implementation, TensorFlow LSTM doc, maybe. Yeah, this is slightly straightforward, nothing to do anything. Yeah, you can see here. So yeah, you can directly import the LSTM cells whatever you had, and these are some of the other parameters you are going to be showcased. So eventually what will happen, whenever you need some of the you can say information to retrieval kind of the